Greetings fellow YouTube viewers. It's time for another compendium video. In today's video, we're going to be learning about voltage. What is voltage? Voltage is also known as potential difference. It's the amount of energy needed to move one unit of charge against the electrostatic force. What do I mean by this? Well, in the last video, we learned about charge. If you haven't watched that, here's the link to watch that. So, we already know what charge is, and we know that like charges repel and opposite charges attract. So, a positive charge and a negative charge will attract, while a negative charge and a negative charge will repel, and a positive charge and a positive charge will repel. So, for the purposes of this video, I will be making an analogy of electrons with water molecules. And this is a really useful analogy, as you will see in the future. So we know that an average electron, a negative charge, doesn't want to move closer to other electrons because an electron repels another electron because they have the like charges. So if you want to move an electron close to something negatively charged, you have to do work. In the same way as, because of the force of gravity, a glass of water doesn't want to move upwards. So if you want to move it against the gravity and put it on a table, then you're going to have to use your energy, the energy that's inside you, use your muscles in order to lift the glass on top of the table. In the same way, if you want to move a negative charge or a positive charge against the electrostatic repulsion force, then you're going to have to use energy in order to do that, and you're going to have to do work. Now the thing about energy, and this is something that applies everywhere, is that you can't create energy and you can't destroy energy. You can only transfer it from one form to another. Even in power stations, they don't create energy, they just transfer it from one form to another. So the energy that you use in just from daily life, the energy that you use in putting something up is stored as potential energy, and you know that. Say you take the glass of water and you lift it up. Now, if you drop the glass of water, the water will release all that energy, and you'll hear a loud noise as the potential energy is transferred into kinetic energy and into sound energy that you hear. In the same way, if you transfer an amount of energy to this electron by putting it in a place where it doesn't want to be, by using energy and doing work against the force of electrostatic repulsion, then you are giving this electron an amount of energy. Now, the amount of energy that you're giving it is called its voltage, its potential difference. So, think about a battery, right? In a battery, you have a positive end and a negative end. Now, in the negative end, there's a whole bunch of electrons that are really close to each other. Now, because we already know that electrons are all negative and like charges repel, we know that they don't really want to be that close to each other. And on the plus side, there's a whole bunch of positive charges really close to each other, and they also don't want to be that close to each other. So what happens is, when you connect the positive and negative ends, a current of a battery, the current flows in between. So the negative charges try to go to the positive place. They try to get away from each other as fast as possible, and in so doing, they release energy which we can use for powering our light bulbs, lamps, heaters, and anything that runs on electricity. So what is voltage? In a sense, it's the amount of energy each electron or proton has because of its position, because of the way it's been moved in the proximity of other like charges. Now, we can imagine this in the same analogy of the glass of water. When I lift this glass up, I'm giving each and every water molecule inside this glass a certain amount of energy. And to find the amount of energy per water molecule, I'm going to have to divide the total amount of energy by the total number of water molecules. And then I'll have the amount of energy in a single water molecule that I've given to a single water molecule. In the same way, if we consider, instead of water molecules, if we consider the electrons, then the potential difference that it has, the amount of energy that basically we transfer to each and every single charge, is equivalent to the total amount of energy used in moving all the charges. So let's say we move 3 or 4 charges. The total amount of energy we took to move all of those charges divided by the total amount of charges we moved is the potential difference. Now, some of you may already know this. The amount of energy or work is measured in joules. If not, I will be making videos about that in the near foreseeable future. Um, if you don't stress about it. It's just the amount a way of measuring work and energy. So the amount of joules divided by the number of coulombs. Now I've talked about coulombs in my video on charge. It's basically a measurement for how many electrons there are, how much charge there is basically. So if you want to find the amount of energy each coulomb can do, then you divide the number of joules by the number of coulombs, and then you get a unit called volts. A volt is 1 joule per 1 coulomb. That means every single coulomb of charge is able to do 1 joule of work, and it's called a volt. It's named after this dude, Alessandro Volta. So remember how I was saying that in order to release this energy, the charges have to actually flow. In the same way as in order to release back the potential energy from a glass of water that's on the table, the water needs to actually flow down. Well, there is a way of describing the flow of electrons in the same way as you can describe the flow of water molecules. And this is called electric current. You may have heard about it. The electric current is what powers our devices. So the voltage is how the electrons get the energy. The electric current is essentially how they release that energy. And we're going to be talking about that in the next episode of this series. So if you haven't already, make sure you subscribe to Compendium. See you again.